Hello everyone, myself Dr. Srinivas working as a professor in the Department of Electronics and Communication Engineering. I have been working for 9 years in this department or institution. So here I am taking a course is called Analog and Digital Communications for second year BTech students. So it is in second semester. So today I'm discussing what is the significance of modulations and a black diagram of communication systems. So the presentation outline of this today lecture is the course objectives. Okay, so before studying this course, what are the objectives of that course? And after studying the course, what is the outcome of the course? So the students we are teaching to the students. Then after teaching this, what students will be getting from this course, and what are the objectives of that course they are going to learn. So these are the things we are discussing. And what is the syllabus of this course? So this syllabus is divided into 5 units or modules, right? The first one is amplitude modulation, second one is angle modulation, third one is introduction to digital communications, and fourth one is passband data transmission, and fifth one is receivers noise analysis, information theory, and channel coding. So these are the 5 units are analog and digital communications course, and this course is very helpful for the students in any government sector examinations and also gate examinations. So especially in gate examinations, it is very easy to track this all the questions whatever they give, so they easily get the marks. So this is very important course, and it is one of the heart of electronics and communication engineering program. So I'm very happy to introduce myself. Now we'll begin with so what is the communication system and these things. So this is the course objectives, the system requirements of analog and digital communication system. That is the main objective. What are the requirements, and the generation and detection of various analog and digital modulation techniques. So where we are using these modulations, where we are using demodulations. So how to generate modulated signal, how to detect the demodulated signals. These are the things we are going to teach now, and theoretical knowledge of each block in AM and FM transmitter and receivers, and also the concept of passband transmission and various source channel coding techniques. So these things we will be studying in this course, and also various noise sources and SNR, signal to noise ratio, and the figure of merit calculations will be discussed in this course. Okay, right. Next, after successful completion of this course, the students will be able to, so they able to understand why modulation is essential for efficient transmission and noise reduction and multiplexing and bandwidth optimization. So that is the main outcome of this, first outcome of this course. Next, the students will be able to analyze angle modulation principles and compare their bandwidth efficiency, noise immunity, and signal power requirements. And they will be able to explain digital modulation fundamentals, like where our course is analog and digital communications. So we have analog modulation schemes as well as digital modulation schemes. So after studying this course, the students will be able to analyze digital modulation fundamentals, including sampling, quantization, encoding for converting analog signal to digital signal form. And the fourth outcome of this course is students will be able to compare ASK, amplitude shift keying, frequency shift keying, phase shift keying. So what are the different digital modulation techniques? What are the comparison? What are the differences among these modulation schemes? So the students will be able to easily compare. And so power, what are the power needs, what is the complexity point of view, and the bandwidth usage point of view, and error performance point of view. The students will be able to compare different digital modulation schemes. Okay, right. Next, the final outcome of this course is the students will be able to analyze how noise affects the communication systems and explore different methods to improve performance using noise characteristics and coding techniques. So these are the outcomes of this present course, that is analog and digital communications. So we can, if you see what is the syllabus and in each module or unit, what are the contents are there, topics are there. So if you look at this, module 1 is nothing but amplitude modulation. So in this amplitude modulation, actually our course is analog communications and digital communication systems. So in analog communications, there are analog modulation schemes. It is one of the modulation scheme is called amplitude modulation, and second one is the angle modulation. So in first module, amplitude modulation, we study what is the significance of modulation, amplitude modulation, time and frequency domain descriptions, and power relations in amplitude modulated waves, and how to generate AM signal, and what is the type of AM modulator, that is the square law modulator, and the detection of AM signal, envelope detector, that is a very important detector, and a generation of DSBSC signal. So in analog amplitude modulation, again we will be having analog amplitude modulation as well as DSBSC, double sideband with suppressed carrier modulation. So again we are moving to single sideband suppressed carrier modulation and introduction to vestigial sideband modulation. So there is a flow. So first we study what is amplitude modulation and we see what are the drawbacks of it. Again we are moving towards the double sideband suppressed carrier modulation. Again we see what are the drawbacks. Then we move towards the single sideband modulation. Then we go for introduction to vestigial sideband modulation. So in all the cases of modulations, what are the generation techniques, what are the detection techniques, and what are the power calculations in each and every generated waves, that we are briefly discussing in this module 1. Okay, next module 2, analog angle modulation. Module 2 is angle modulation. So angle is nothing but suppose if you take AC cos 2 pi FCT plus some pi, so some theta. So here this part is nothing but a frequency part, this part is nothing but a phase part. So combination of frequency and a phase part together is called angle. Okay, so in this case there are two important parameters. One is the frequency, second one is the phase. Okay, so here in angle modulation, so like how we are studying amplitude modulation, so in angle modulation also we are going to study what is the frequency modulation, what is the phase modulation. So that we are briefly discussing in this module 2. Okay, and in this module 2 also we see what are the generation techniques for frequency modulated wave and phase modulated wave, and the detection already as well as generation and the comparison of amplitude modulation, frequency modulation, and phase modulation we see, and different multiplexing techniques also we will be studying here. And module 3 is introduction to digital communications. The first two modules covers analog part, and the next followed by module 3 and 4 will be covering this digital communications part. Okay, so especially we see what is the digital communication block diagram and advantages, and what are the digital modulation schemes and advantages and techniques and generations, detections. Okay, we see in detail in module 3. Okay, so like AM, FM, PM, so in this digital communications also we will be having PAM, PWM, DM, DPCM, ADM, okay, and PPM. So there are some other modulation techniques like ASK, FSK, PSK, and QPSK, right? So these are all the different digital modulation techniques we are going to study in unit 3 and unit 4. So in unit 4, so especially we are discussing passband data transmission. In unit 3, we are discussing baseband data signal transmission. We are studying in unit 3. In unit 4, we are studying band pass or passband data transmission. We are studying in the unit 4. So for band pass or passband data transmission, we are having different modulation schemes, and for baseband data transmission schemes case, we will be having different modulation schemes. Okay, so this is module number 4. Now module number 5. So this is entirely we are covering the receivers and the transmitters and the noise analysis in communication systems in both analog and digital case, and we study information theory and coding. So information theory and coding is a vast syllabus, but we try to learn what are the channel encoding techniques, what are the source encoding techniques, so that we study at least in this unit. Okay, right. Now these are the textbooks we are suggesting you. We are also going through these textbooks, especially Simon Aikens, Analog and Digital Communications, John Wheely 4th edition, and some reference textbooks also there. So we can go through. These are the textbooks are very, very important for GATE point of view as well as for your semester examinations point of view. And the first unit or module is amplitude modulation. So in this amplitude modulation module, first topic is significance of modulation. Okay, so that we are discussing now. So there are so many topics are there that the remaining topics will be covered in the next lecture. So the first we are discussing significance of modulation. So in this first, what is the communication system? Okay, so communication involves transmission of information from one point to another point through a succession of processes. Okay, I am speaking, you are all listening. So I am a transmitter and you are all receivers. Means you are receiving my information. So this is called conversation. I am speaking and you are listening, means that is called conversation. Suppose one person is long away from my place. So if I speak, he cannot listen because he cannot get my voice. So in that case, how to communicate with that person who is away from my place? Okay, so in that case, what we are doing, we are designing a communication system that is called electronic system. Okay, then my speech is nothing but a non-electrical signal. So this non-electrical signal can be converted into electrical signal. Then I can transmit my electrical signal through some cable, through some wireless channel or wired channel. Okay, then the receiver side, the person who is away from my place, so he will be also having a receiver. Then he will receive my electrical signal. Then again that receiver will be having transducers. It will convert back this electrical signal to non-electrical signal, means my voice. So this is called, what we are observing in this discussion is you are transmitting electrical signals from one place to another place. So what is the signal now? So signal is nothing but it consists of information to represent the physical phenomena, right? So generally definition is signal has a one or more independent variable. It gives the information to represent the physical phenomena, right? So this is called electronic communication. So normally if I speak and you are listening, that is a conversation. But when we are sending electrical signal from one place to another place, my place to that third person place, so that is nothing but electronic communication. So this is a block diagram of communication system. So it consists of source information, so that is our side, and user information or destination side, so that is this one. So this entire block is nothing but a communication system. So in this communication system, the main parts or blocks are transmitter, receiver, channel. Okay, so I am speaking, you are listening, there is a channel, right? So transmitter is transmitting our signal, and the receiver is receiving our signal, and again the destination side, the receiver, okay, the user information, user receives my information, Okay, so between transmitter and receiver, there is a block is called channel. So this is called a channel. So every signal is passing through channel. So channel can be wired channel. Channel can be wired channel. The best example for wired channel is coaxial cable. Coaxial cable. Okay, and twisted pair cable. Twisted pair cable. Okay, and we can take fiber optical cable also. Fiber optical cable. Okay, so these are the wired channels we are using. Okay, now if you take wireless channel means that is nothing but free space. There is no cable, there is no wire. Okay, so in this case, so every signal from transmitter is passing through cable. So that is nothing but wired channel. So if you take wireless channel, means there is no okay, cable. So that is nothing but wireless channel. So when you are using wireless channel, we need compulsory an antenna at the transmitter side. So this is antenna at also receiver side. So we need antenna. So this is a free space. Okay, free space, because we don't have any cable here. So in that case, we need definitely antenna. Okay, so antenna, transmitting antenna as well as receiving antenna. Now here channel is free space. Now point is, in transmitter block, in receiver block, what are the sub blocks are there? That is a very important thing. So in transmitter side, we will be having modulator block. So this transmitter consists of modulator block. At the same time, receiver side, we will be having demodulator. If the modulation technique is analog communication technique, so that system is said to be analog communication system. If the modulator type is digital communications technique type, so that is nothing but a digital communication systems. So here, if I use AM modulator, as I discussed in the syllabus, we will be having amplitude modulation and double sideband suppressed carrier modulation, or if you use angle modulation, frequency modulation, so that these things will be there in the transmitter side. Okay, if you use AM modulation, modulator, that is called AM system. If you use FM modulator at the transmitter side, that is called FM system. Okay, so at the receiver side also, we will be having demodulator technique. So I will tell you briefly what is the modulation technique, what is the demodulation technique, everything I will explain in the next slides. But here, what are the sub blocks are there, you need to understand first. In the receiver side, we will be having demodulator. So again, if you are using FM modulator, here FM demodulator. If you are using AM modulator, you are using here receiver side AM demodulator. So like that, we will be having different modulation and demodulation techniques in our communication system. Okay, these are the elements. This is a general block diagram of a communication system, right? Next, what is the need for modulation? So here, very important point is why we are using modulation technique in this transmitter side. That is very important. Suppose we know in communication system, what are the signals can be transmitted. So the first signal is nothing but a voice signal. So everybody is having mobiles. Okay, so definitely we need to transmit our voice signal. That is for communication system. Okay, and second one is we can transmit audio. So audio signal. So audio signal frequency range is 20 hertz to 20 kilohertz. Okay, but what about the voice signal? That is a 300 hertz to 3.5 kilohertz. So voice is a part of audio because 300 Hz to 3.5 kilohertz is a part of 20 Hz to 20 kilohertz. And third one is a video signal. Video signal. Okay, video signal transmission. We need to transmit video signal. So what is the range of frequency? That is nothing but 0 to 4 megahertz. 4 megahertz. This is a video signal frequency range. And the fourth one is the data signal. Data signal. So that is nothing but a data signal, and it doesn't have any frequency range. It depends upon the width of the data signal. That is the width or duration of the data signal. Suppose its duration is TB and its frequency is 1 by TB. Okay, so if dp is 1 milliseconds, okay, bit duration, so that is nothing but 1 by 1 milliseconds is nothing but a 1 kilohertz. So here data signal doesn't have a fixed frequency range, so it depends upon the duration of the bit or bit duration. Okay, so these are the different signals we are transmitting in communications system, using communication system. So in this case, so first you take voice signal frequency range. What is the frequency range of voice signal? 300 Hz to 3.5 kilohertz. Now our focus is, why do we need modulation? So why do we need modulation? Physical dimension. First one, to reduce physical dimensions of the antenna. Okay, physical dimensions of the antenna. Now how to measure physical dimensions of the antenna first? So before modulation, without modulation, with the modulation, so how to what is the physical dimensions of the antenna? We'll check it, then we can understand so what is the need for modulation. So without modulation, with modulation, so we'll check what is the physical dimensions of the antenna. The first advantage need for modulation is to reduce the physical dimensions of the antenna. So we are able to reduce the physical dimensions of the antenna. That we'll check in detail. See, for example, see, I'm having an antenna. So this is an antenna. Okay, this is a ground. Okay, so I want to design this antenna. So the height of the antenna, generally we measure in the order of lambda by 10. Okay, maybe meters, right? So here we know when we are transmitting our voice signal. So voice signal frequency range, we know it is 300 to 3.5 kilohertz, and we know what is the relation between signal frequency and the velocity of a signal. Okay, speed of a signal, right? C equal to f lambda, where lambda is the wavelength of the signal and f is the frequency of the signal and c is the speed or velocity of a signal. So in this case, lambda is equal to c by f. Okay, we know velocity of a light is nothing but velocity of a signal, that is nothing but 3 into 10 power 8 meters per second, or 3 lakhs kilometer. By frequency, let me take 300 Hz is my signal frequency. So this is I am taking without modulation. Directly I am finding what is the lambda. Then I will substitute this lambda in this. Then I will see what is the height. What is the height of this antenna, that I want to see. So what is my aim? I need to find what is the lambda first. So lambda is equal to, so here 10 power 8. So here 2 zeros, 2 zeros get cancelled. So you will have in 10 power 6 here. So 3 get cancelled. Finally you are having 10 power 6 meters per second, or meters. So this is hertz na. So this seconds, this per second get cancelled. So 10 power 6 meters. Then if you substitute here 10 power 6 by 10 meters, so 0 get cancelled. So 10 power 5 meters height is required of this antenna to transmit, to radiate my voice signal with the frequency is 300. So designing of this 10 power 5 meters height of the antenna is not at all possible. It is almost okay. So 100 kilometers antenna you cannot design. Okay, so 100 kilometers antenna you cannot design. Why do we design this 100 kilometers? Because my signal frequency range is only 300. So in this, what is my observation here? If I increase the frequency, so then what happens? Lambda will be reduced. When lambda will be reduced, so this 100 kilometer will be reduced. Height of the antenna will be reduced. So in this case, I want to increase 300 hertz to some other frequency, high range frequency. But how to increase this high frequency 300 to high frequency? So for that we need to review Fourier transform property. Okay, so that is nothing but frequency shifting property of Fourier transform. So frequency shifting of Fourier transform, we know. So let me see, have a look on this frequency shifting Fourier transform once again, then we'll come back to this. See here, frequency shifting property of Fourier transform. Suppose I have only 300 hertz signal. I have g of t. Whenever you are multiplying with exponential j 2 pi fct, fc is the high frequency signal. So whenever you are multiplying high frequency signal with the original signal, so here what is the frequency shifting property of Fourier transform? So you are observing that f minus fc. If you take here minus j minus e power minus j 2 pi fct g of t, if you take minus here, then what is the Fourier transform? We are seeing g of f plus fc. So original signal frequency is f. Now after frequency shifting property, if you apply Fourier transform, now frequency is increased from f2 to fc. So f2 to fc, you are increasing. So okay, so in this case c by lambda, c equal to f lambda. Okay, lambda is equal to c by f. So f is increased now. So f is generally it is nothing but f plus fc, right? Fc is the high frequency carrier in communication system, especially in mobile communication system. We will be using 800 megahertz frequency we are using for as a high frequency carrier. So I will tell you what is the modulation, what is the carrier, what is the modulating signal, baseband signal. I will tell you later. So our aim is to, what we are discussing now, our aim is to how to reduce the physical dimensions of the antenna. Okay, so here see, using this frequency shifting property, I am able to increase the original frequency to f plus fc. So here original frequency is 300 hertz. Now I am able to increase 800 megahertz plus 300. So c by f. So c is 3 into 10 power 8 and 800 mega means 10 power 6. So 800 means 8 into 10 power 6 plus 300. So it is approximately, okay, so 10 power 6, 10 power 6, 10 power 8. So these are all 800. Na? So here this is also 2 zeros are there. 10 power 6 is there. 10 power 8 get cancelled. And finally you are able to get almost 3 by 8 meters. 3 by 8 meters means it is very less. Again, you need to take 1 by 10. Na? So 1 by 10. So 3 by 80. 3 by 8 is a very small value. Oh, so in this case, you can reduce the physical dimensions of the antenna using modulation. Now, what is the definition of a modulation? Simply, I will tell you what is the modulation. Modulation is converting low frequency 300 Hz signal to high frequency. We are converting low frequency signal to high frequency signal using modulation. So without modulation, the height of the antenna is 300, 100 kilometers height is required in order to transmit 300 Hz voice signal. Now using modulation, so we require only 3 by 80 meters of the antenna to transmit our 300 Hz signal. Okay, so this is the significance of modulation. There are so many advantages or significance of modulations are there. So that will be discussed in the next lecture. So I think what we have studied as of now, so we have seen what are the objectives of the course and outcomes of the course, syllabus of the course, and textbooks and reference textbooks, and especially what is the communication system block diagram, and in each and every transmitter and receiver block, what are the things are there, what are the sub blocks are there. Okay, and finally we have seen what is the significance of modulation, so without modulation, with modulation. So especially we have seen how to reduce the physical dimensions of the antenna. So I hope we have understood thoroughly. Right, thank you.